Okay, 9.2 is on the binomial theorem. So we'll look at powers of binomial, Pascal's triangle, and the binomial theorem, and some factorial identities with homework. Okay, here's basically the binomial theorem. If you have a plus b to the 0th power, well, that's just obviously 1. If you have it to the first power, we know what that looks like. We can write it like this, though. If you have it to the second power, then it's 1 a to the second b to the 0th plus 2 a to the first b to the first plus 1 a to the 0th b to the second. So these come from the second row of Pascal's triangle, the coefficients. So those come from, and I'll show you this more in a second, but this comes from 2c0. This one comes from 2c1. This one comes from 2c2, which is our combinations, which is the second row of Pascal's triangle. I'll show you again. And then what the pattern is that you follow is you start off with the highest power here, and then you lower it by 1 and raise the other power. So now this power went from 0 to 1, and so the first power here is going down, and the second power that I've circled here is going up. Okay, you just follow that pattern. So the same thing with the third. This comes from these coefficients come from the third row of Pascal's triangle, and you start off with a to the third, b to the 0th. You raise the exponent on the you lower the exponent on the first one and raise the exponent on the second one. That's the binomial theorem, and that allows you to expand anything you want to any power in a much quicker way than actually multiplying all these factors out. Because as you know, a plus b to the 5th, if you had to multiply that all out, that would take a while. As you know, you'd have to write it out 5 times. You have to FOIL the first 2, and FOIL the first 3, and then so on. So if we're going to expand a plus b to the 4th power, as an example, then we would do 4c. You can start off with 4c0 or 4c1 here. It doesn't matter. Then you have a to the 4th, b to the 0th, plus 4c1, a to the 3rd, b to the 1st, plus 4c2, a squared, b squared. I'll have to go down here. 4c3, a to the 1st, b to the 3rd, plus, and then 4c4, a to the 0th, b to the 4th. So you could simplify this. This comes from the 4th row of Pascal's triangle. So when you simplify this, 4c0 is 1. 4c1 you can do in the calculator is 4. 4c2 you can do in the calculator is 6. This is 4, and this is 1. So it's symmetric, like I said. So you could have started with 4c4, and you'll see that you could have switched these coefficients. But when you simplify this, then you get 1 a to the 4th, b to the 0. That's just a to the 4th. Plus, then you get 4 a to the 3rd, b to the 1st. Plus, then you get 6a squared, b squared. Then for the next one, you get 4a to the 1st, b cubed. And then the next one, you get just b to the 4th. So you can simplify it like this, and that is your expansion of a plus b to the 4th power. Okay, here's Pascal's triangle that I've been talking about. Here's the 0th row. Here's the first row. Here's the second row. So these give the row number right here I've been talking about. So we just a second ago used the 4th row of Pascal's triangle, which there's the coefficients there. And where these come from is this is 4c0, this is 4c1, and so on. This is 4c2, and this is 4c3 as we just did, and this is 4c4. Okay. One of the properties about this that's, I guess, interesting is that if you add the 2 above these two, you get that number. So it's, if you add these 2, you get the 10. It says Pascal's triangle has a lot of weird application, but that's one of them. And this says right here, says the same thing as I just showed you up above. You can actually try it if you want. Like for this one right here, this is 4c1 plus 4c2 gives you this would be 5c2. And you'll notice that follows along with this exactly the way I wrote it. Okay, so here's the binomial theorem. We've been using it. We just used it to do the expansion, so I kind of explained it to you already. This is really just nc0, right? And then you just follow this pattern where the next one's going to be nc1, and you lower the exponent on the first term and raise the exponent on the second term, which is exactly what we were doing. Okay, let's just do one more example, and then this one's a little bit harder. But we're going to expand this, so we have 5c0. Like I said, you can start off with 5c5 if you want. Then you have z to the 3rd power, so raised to the 5th. Then you have the next one, negative 5x squared raised to the 0th. And you just follow this pattern where you're going to write this out. So it's 5c1 now. This z to the 3rd that was to the 5th power now goes to the 4th power. And this negative 5x squared that was to the 0th power now goes to the 1st power. Okay, so next we have, just follow this pattern. So you're increasing this number, so it's 5c2. You're decreasing this number, so it's that z cubed, the exponent on that is going to go to 3. And you have negative 5x squared, and the exponent on that is going to increase. So I'm going to pause it now and rewrite the rest of it. So I'll start down here and just write the rest of the terms, which there's only 2 more terms to write. I'm sorry, there was 3 more terms to write. But once I have those terms written, so to simplify these, this goes to 1, and so does this. This 5c0 is the 5th row of Pascal's triangle. So we have 1, this is 5, this is 10. And once again, you can do this out on your calculator like we did. This is 10, this is 5, and this is a 1. So when you go to simplify this, I know it's a lot of work, but we have z cubed raised to the 5th, so it'll be z to the 15th as our leading term. And then you just follow this. So it's going to be z to the 12th. So I have 5z to the 12th, and this is negative 5x squared, so times negative 5x squared, plus, that takes care of this, so let me get rid of those. So then I have 10 times, this is z to the 9th, and the next one I have 25x squared. Okay, so that gets rid of that. Next one I have 10, and then I have z to the 6th power times negative 125 to the x squared cubed would be x to the 6th. Plus, gets rid of this. 5 z to the 3rd. And then I have negative 5 to the 4th power is positive 625 x to the 8th. That gets rid of the second to last term. And then the last term, I have 1 times 5 to the 5th power, which is 3,125. And that's negative because it's an odd power, x to the 10th. So I do need to simplify this a little more now. I know this is a ton of work, but it simplifies to z to the 15th plus negative 25z to the 12th x squared plus 250, so order doesn't matter, so I'm multiplying in whatever order I want, plus the next one would be negative 1250 z to the 6th x to the 6th, and then I have 5 times 6 25, which would be positive 3,125 z to the 3rd x to the 8th, and then the last term, negative 3,125 x to the 10th. So that's the full binomial expansion of this right here. I know it's a lot of work, but you know, it'd be a lot more work to actually FOIL this out, the whole thing. So this is going to save us a lot of work, and we are going to have to do these. Maybe I won't give you the 5th power on the test. Maybe I'll give you the 3rd power or 4th power, but we are going to have to do this. All right, I hope this helps.